I'm back from taking some time off for my birthday, and we're going to move into a small lesson just so I can slowly get back to speed. This one is going to add some additional key press functions for the game, and we're also going to fix a bug that could occur if the player presses a key in a certain situation. And that situation is for our tab control down here with the inventory, quest, and recipes. If you clicked on one of the items in the inventory or in the recipe control and you pressed a key, the way WPF normally works with your data binding is it's two ways. So the UI can read values from the objects, or it can set values from the UI into the object properties. And the problem was many of our properties are get onlys. So for instance, here in our inventory, we show the description, which is pointy stick. If we look at the code for our inventory tab item, we bind to the game item's name property. And then if we go look at the name property, it's get only. The name property can only be set in the constructor. And the problem is with the normal two-way binding, if someone had focus here on the inventory item's name and pressed a key, the program would try to set the value on the property with whatever the user pressed, which it can't do because there is no setter and the program would crash. So the first thing we're going to do is fix that bug. And we do that by going into the XAML, our mainwindow.xaml file, finding our tab item and the data grids, and for everything that we're bound to in our data grid text columns, we're going to add comma mode equals one way. So now the UI knows it can read values from the object for the data binding, but it can't ever try to set values on the properties. It's not a two-way binding, it's just a one-way. And we need to do this for all of our data grid text columns that have bound values. That's here on line 175, 180, and 182 for our inventory items. And we're going to do the same thing with our quest data grid text columns on lines 195 and 198. Just add the comma mode equals one way. And then we do the same thing on our recipes tab item for the recipe name. So now if the player runs the game, clicks on one of the inventory items, and then clicks W so they can move north, they just move north. The program doesn't try to change the description of this item to one that starts with W. The next step is to add some more functions that work off of the key press. Someone asked if we could change the program so that you could press a key and then have the inventory tab show up as the highlighted or the top one in the tab control. Press another key and have your quest show up, have another one and have your recipes show up. So we're going to add that. Plus I'm going to add, if you're at a location with a trader, if you press T, then the trader screen will pop up. We'll start with the tab controls. In order to access those from the code behind, from the mainwindow.xaml.cs, we need to give them names. So in mainwindow.xaml, we're going to start by giving the tab control a name on line 167. We set this new attribute, x:name equals player data tab control. So this way in our code behind, when we want to say for this tab control we want to change the focus, whichever tab item is visible, we know which tab control we're working with. And then for each tab item, we're going to set an x:name attribute for it. For the inventory one, we'll set the name to inventory tab item. For the quests one, we'll set the name to quests tab item. And for the recipes tab item, we'll set the name to recipes tab item. So now when we go into mainwindow.xaml.cs, we can create this new function on lines 108 to 121 called set tab focus to, and it takes a tab name parameter. This is going to say for each item in the player data tab control items, and that player data tab control is the name of the tab control. So that's how we access it in the code behind. And the items is anything inside the tab control. And here in the XAML, if we look at that, we have 3 tab items inside the tab control. We're going to loop through each of those items. Then we're going to check to see if the item is a tab item. Then we're going to assign it to the variable tab item. I'll explain a little bit more about this line here because it might look a little bit strange, but I want to go through the loop first. Basically what this does is it says in the player data tab control items, we're going to look at each item, check to see if it is a tab item object, because for some controls, you could have different things inside their items collection. If it is a tab item, then we're going to check to see if the tab item name, looking back at the XAML, that's those new x:name attributes that we set on each of these. If that name matches the name of the parameter we passed in, then we're going to say that tab item is selected equals true. And then we're going to return just because we don't need to check any of the other tab items. And this is selected is what's going to bring that particular tab to the top. We could reference this instead of looking at names on each tab item. We could reference it by the index value. So I could say player data tab control items 1, which would be the quest tab item, because remember the items are zero based, the collection is zero based. But then if we ever rearrange the order of the tab item controls, then our code wouldn't work the way we expect. We would press the key for the quest one, but then the recipes tab item would show up as a selected one because we're going off of just the order that they're in and not a specific name for each tab item. And in order to use this, we'll go back to our initialize user input actions and add lines 94, 95, and 96. And this will say if the key press is an I, then we want to run the set tab focus to inventory tab item. So that will look through the tab controls, find the tab item named inventory tab item, and then that's one that's going to be selected. And for Q, we'll set the tab focus to quest tab item, and for R, we'll set the focus to recipes tab item. For the T key, we're going to do something a little different. For the movements, for the WASD, we went into the game session object and called the move north, move west functions. That's because the game session had some additional code in there. So if you move to a new location, it would check to see if you could turn in a quest. It would check to see if there was a monster there. If there was, it would create a new monster and set that to the current monster. Had a lot of other logic happening. So we had to call into the game session function because we were going to do other things inside the game session object. With the T key, all we're going to do is something in the user interface. In that case, we're going to display the trade screen. We already have an existing function, onClick display trade screen, on lines 69 through 78. And this is the one that if the player is at a location, we have a trade button that becomes visible. And when they click that button, this is how the trade screen gets displayed. So we're just going to reuse that here in our initialize user input actions function. And we're going to say call that function. It takes two parameters, the sender and the routed event args. So we'll send this object as the sender. Really doesn't matter because we don't use anything from it. And we have to pass in some routed event args value. So we're just going to instantiate a new one and pass that in. Because again, we don't really care about any additional arguments. All we're going to do is show that new form, that new window, so we can just pass in basically nothing. We do need to make one change though to the onClick display trade screen, and that is to wrap it with a guard clause, this if statement on line 71. Now that the player can press the T at any location, even if there is no trader, we want to check to see if there is a current trader. If there isn't, then we're not going to display the trade screen. If there is, then we'll go ahead and display the trade screen. And before we test this out, I'll go back and explain the part I said I was going to explain, and that's in our set tab focus 2. This line here, 112, we're checking to see if this item object is a tab item, and if it is, we're assigning it to this new tab item variable, whose data type is tab item. This might look a little strange. Another way of writing this would be like this. So here we're going to say cast the item as a tab item and then save it into the tab item variable. And we're going to say if tab item is not equal to null, then do the code inside the if. So really, this new line here inside this one line inside the if is kind of combining these two lines here, saying cast this. If you can, assign it to the variable. If you can't, then your if is going to evaluate as false and it's not going to run the code. So let's take a quick look at the game now. And with the changes in, if I click on a game item and I press W, I move to the north and the program doesn't crash. If I hit the T key, the trade screen pops up. If I go south to a location where we don't have a trader and I hit the T key, nothing happens. So it looks like all those changes work. In the next lesson, I'm thinking of switching the factories so they get all of their data, the monster information and the weapon information and the game item information from XML files. So that way it's easier for you to customize the game. You can just make the changes to the XML files. You don't have to recompile the whole program with the new factory classes with your new monsters and locations. There are several other features I want to add eventually. Armor, magic, better combat. If there's something that you want to see in particular, let me know. I can prioritize the next features, however people want to see it. Just leave a comment here on the YouTube video or on the lesson page on my website, which as always will have the source code for this lesson, the changes. And if you have any questions, you can also leave your comments there, and I'll get back to you as soon as possible. Thanks.